Hi, my name is Eyal Shekel. I'm the CEO of Civan. Thank you for joining us in this webinar about dynamic beam for material processing. Just a few quick words about Civan. Civan is manufacturing high-power lasers based on coherent beam combining technology. We are a vertically integrated company controlling all the core technologies in-house, from the basic components through building of the fiber lasers and integrating the complete system. We are in operation since 2008. With 180 employees and facilities of over 4,500 square meters, we delivered over 300 kilowatts of laser output over the last 2 years. We are working with leading companies as customers and partners, some of which you can see on this slide. So let's start. The core technology of Civan is coherent beam combining, or CBC. This means that we can take hundreds of amplifiers and combine them to create one single mode output beam. Each amplifier can provide up to 1 kilowatt, so overall we can provide more than 100 kilowatt of combined single mode output. The second part of the technology is optical phased array, or OPA. The idea is that light is emitted from many coherent sources in parallel. The beams of the individual sources overlap and create a combined beam. The shape, position, and focus of this combined beam can be controlled electronically with no mechanics, no optics, and no moving parts. This way, we can manipulate the beam in nanoseconds at very high power and no mechanical or optical limitations. This ability to manipulate and move the beam to any desired shape or position in nanoseconds is what we call dynamic beam. We can control the beam shape and position, create a sequence of shapes, control the speed of the motion of the beam, and dynamically control the focal distance, all in a completely digital, flexible control in speeds of up to tens of megahertz with no moving parts. The dynamic beam laser is a new class of laser. It gives powerful dynamic control of the melt pool, enabling many exciting possibilities in material processing. Applications include welding, cutting, drilling, additive manufacturing, and surface treatment. Let's see how it works. The first step is to design a desired beam shape. We provide a very simple tool to design any shape. The user can basically draw a shape with his mouse and immediately see what the beam will look like. With another click of the mouse, the beam is loaded into the laser. Then, by running different shapes, one can optimize the beam shape to the specific required process. Here we see an example of stainless steel. We see two shapes of a beam, while the other parameters are the same. It is clear that the shape on the left is creating very unstable keyhole, while the shape on the right is creating a nice and stable keyhole. This is only an example. As we know, for every process, we need to optimize the parameters. The dynamic beam allows us to design and choose any required beam shape. Another unique feature is the ability to change the speed of the beam steering. By steering the beam at megahertz, we get a quasi-static shape, as seen on the left. Or we can move the beam at kilohertz or less to steer the keyhole in the melt pool. And again, as expected, the frequency of the beam steering has a fundamental effect on the cross-section. As you can see here, different cross-sections with the same beam shape and the same other process parameters, where the only difference is the steering speed from 0.5 kilohertz up to 70 kilohertz. We can also design several different shapes and switch between them to create a sequence of shapes. Here you can see again our software tool for beam design. A sequence like this can be very useful to create sophisticated control of the melt pool. Another interesting application is for drilling through a multi-layer structure. We can design a specific beam parameter for each layer and change the beams as we drill through the different layers. One last example is the control of the focal distance. Since our laser is single mode, we have an inherent large depth of focus. But in addition, we can steer the focal point. This can be done as fast as megahertz or slower as desired. Here we see some results with clear effect of the focal steering. The two top cross sections are cut with different shapes with fixed focus. The bottom cross sections are with focus steering. It is clear that the focus steering has a significant effect on the results. So to summarize, the features of the dynamic beam are the ability to create any arbitrary shape, steer the beam fast and slow as desired, create sequences of shapes, and do focus steering. The benefits are clear. Having full control of the melt pool opens up many new possibilities that are very difficult or impossible today. Some examples are welding of dissimilar materials, welding of crack-sensitive materials, having spatter-free and porous-free welding, cutting and drilling fast and clean with less druce and good surface quality, doing additive manufacturing at high power and high speed with full control of the melt pool, and so on. We are showing here two examples of things we did recently. On the left, we see welding of copper to aluminum. As you can see, by just changing some beam parameters, we are able to completely change the nature of the weld. On the right, we see welding of aluminum 3003 series at 15 meters per minute with excellent weld quality. Another important feature that I want to mention is the ability to rotate the beam shape on the fly to always be in the right orientation relative to the feed direction. This, of course, is easily achievable with our dynamic beam because of the ability to do real-time changes to the beam shape. In the future, we hope to have real-time feedback from different sensors that can do real-time control of the dynamic beam to continuously optimize the process. Finally, I want to show some examples of integration of our laser into workstations. Here you see two examples of integration into gantry machines for cutting and for welding. One is by BBW Laser Technique in Germany, and the other is by SLTL in India. On the left here, you see a DED setup, and on the right, a setup with a robot. In all these setups, there is a smooth and easy software protocol to control the laser and the dynamic beam in real time. We also have a small application lab in Civan where we do demonstrations for customers. We have here a 14 kilowatt OPA laser, and we can do proof of concept and process development for customers. To finish this talk, I'd like to present our current product line. On the left is the OPA 6 laser with dynamic beam and power of up to 28 kilowatts, and the OPA 12 on the right with dynamic beam and power up to 100 kilowatt. Both laser types are in production and installed by customers. Thank you very much.